Hello again. Sorry for the delay. I just want to complete the last one. The HTTP client example. The last time I used this thing actually was to generate this page. Find it. To be my favorites. Reference. Sharing. This one, I think. Yes. Now that should be instant. This is on my local hard drive. Okay. Well, I don't know why there was a delay there. Probably because this has been idle for a while. But everything else you click here is fast. And the reason is because all these files are local. And it includes pictures. I got the pictures and everything. If I can find one. Let's see. Whoops, not create. Next. Here we go. These are pictures. See? This Chrome has a feature that allows you to pretend like you can drag things around. But these are in fact pictures, not text. If it was text, I could select the text, but I can't. View the source. Okay, so there's not much to this source, and so it was kind of lucky that that page, it turns out, is in a pretty simple format. I think I put in code to look for and remove references to anything online, but there weren't any. But you can do that. So you can. Now I still have the code for that. It's not in here. I wouldn't have been able to make it here, but it would certainly be in my other project. My other projects root or the workspace, I should say. This always takes a long time. This doesn't have to do with the recorder. I don't know what it's doing. COM. Something to do with COM. Guaranteed. Oh, got there finally. Okay, now my lab. Is that where I am? That is where I am. This is actually where the last thing I did here was this. And here is the code for that. And here is some website. Here is where I wanted to place it. And I don't know why I'm removing that file. Oh, I see. That's because I'm not. This is the code for a reattempt. In which case, I had to remove a file. I think I can make this happen in one go now, and maybe it won't. But the way this code works is that if it finds a file and it's seen it before, then it won't attempt to parse it or something like that. We can just grab this code as is. And so another transplant. easier one. Now I got a bunch commented out too. Hopefully I need to just make a mark so I know which is which. Okay. We shouldn't need any of this stuff. We have that already. Okay, we'll include this one. And we don't need, we might need this, I don't know. I don't have a file class yet. This is unnecessary. In my old code, before I figured out how to do that automatic initializing of common before main gets entered, I did that by declaring a static variable. And in the constructor, it would do the initializing of my common. So if anything was declared static, it might have gotten executed before this, but that now is no longer a possibility. Clear comments, I'm sure we need that. I'll put this down below. Now, these are just little utilities to modify the HTML. Copy from remote. This is the whole, like I'm supposedly downloading an entire website by method of clicking every possible button. And it was my theory that if you did that from the root, you should obtain the entire website. Okay, comment this. Get rid of this. And my name should be here. Okay. These don't have to be where they are. They happen to be there now. Okay, now that I didn't do that. Why did it do that? I'm missing a bracket somewhere. Okay, there's no such thing as TW file. So we'll have to leave this unimplemented for now. And just get the structure down. This has no file stuff. And those are not, this is not Unicode. Well, we can change to debug build. Okay. That's probably, okay, nothing, no file stuff there. It exists. I still have that function. No. I think I have file exists. Well, it's not complaining. It's still doing its intelligence. Its intelligence is being updated. I should turn this off. It's going to consume. Oh, I'm getting good. Never mind. Found it. There is such a thing. Okay. string and file can't do. Just comment this away for now. Okay. Now this is the outline of the program, and what I've got here, this is something I was trying to find that limit for the invisible registry keys, and I found the limit, but it's strange the way it works. Something I'll mention another day. It doesn't. Sometimes everything gets removed, even though only one of them is in the secret format. I don't know exactly why that is. Okay, now this here. Oh yeah. Now before going on, I should mention one of the good things about doing something like this with your old code is that you find mistakes. And I did find a mistake, and I wanted to mention it. It's an important error, and one that a lot of people make, and that you'll even find made in the help file. Actually, I just put a comment. All I gotta do is recompile this. I don't remember where it came up before, but I know it's come up before where you have a function like a operating, or either a runtime library function or operating system function call, where there's a parameter that takes a pointer to it, usually a file name or something, but it's not declared as constant. And so what people do is they tend to just take a regular string literal, and cast it as a non-const pointer to car or something. And that would be a mistake. And I can't remember which function it was. But one of them, and the help file even supplies in their example an example of doing the same thing, casting a pointer to constant pointer to non-const, and I did that with a string literal, and the program crashed. It crashed because that string, even though in the end it hadn't been modified, was written to. So that the string, even though in the end that string, according to the help file, is not modified. If it's declared as non-const, then it must be non-const. Here. And here I've made that error. Okay. This is a function that built like an operating system function, nothing to do with this class. To send an HTTP request of whatever type, and it takes some parameters. So one is, well, you can see here, some kind of handle, some kind of string representing header type, the length of the first field, and then the next thing is an LP void, additional data in the request. LP void, no const, and then the length of that buffer. Okay, so therefore, in doing what I've done here, I've made a mistake. That's an error, because this is a constant. This returns a constant buffer, and the argument here, well, let's find it in the help file, explicitly says non-const. If it says non-const, then you don't pass constant things in. Even if it may not modify those, it might not modify that in the end. It may write to it, and that does happen. Okay, here's the help file. I don't know if I can make the font bigger. Control plus. How do I make the font bigger? It should be bigger anyway. There we go. Send request to HTTP Hypertext Transfer Protocol server. We need an H internet, whatever that is. A constant string. SZ means null terminated. Okay, so a long pointer to a null terminated tcar string that contains additional headers to be appended to the request. Can be null if there are no additional headers. And then LP void optional. Pointer to a buffer containing optional data to be sent immediately after the request header. This is generally used for post and put. The optional data can be a resource or information being posted to the server. So if it's like a picture or something, it could be that kind of data and can be null. The size of the optional data in bytes. Okay. Now, I don't know why this one is constant and this one is non-constant, but it is constant, and so therefore we can't pass. It's non-constant. Non-constant means that this function it should be that the default is constant, and then you have to specify something, to make something non-constant. Because as it is, this is not a suggestion, right? It's not this type declaration or whatever doesn't say, maybe give me a constant or non-constant pointer, up to you sort of thing. This is a command, and the command says that the buffer here being passed in is going to be modified. And that's the end of the story. It's going to be modified, so, pass in something that I can modify. Don't pass in constant. Now, it turns out that nothing bad's ever going to happen here because well, except for one case, this cster never returns a literal constant. It returns something declared as constant, but it's actually most of the time a malloc buffer. Except for the case where the string itself is empty, in which case it returns a valid pointer to something that can't be written to of length 0. If you look at the TS string, it turns out that when the thing is empty, that C_SZ function still returns a valid pointer. See? If there is a string, return it, otherwise return this. I don't have to, I could always return this, and then you would get actual null strings out. But I thought it would be safer to make sure that you always get something out that's valid. Even, you're not allowed to write to it, so it's fine for me to return this literal, which is actually 1 tcar long, right? And contains the number 0. But if you tried to write to that, you would get an access violation. So in this case, so even for a TS string, there's the possibility of this causing a crash. even though length it says 0. Well, no, actually it won't. It won't, because length would be 0, and this doesn't say anything about null termination, so it won't write beyond the amount of data given. Turns out it's still an error and should be dealt with, and it's easy for me to deal with that because I have a thing called auto dupe, which does a stir dupe. I don't know why it didn't come out. Oh, that's it's not even the. I want to see the argument. Name, dupe, what I give it, and some threshold. That threshold again just says defines what size it will use not use the stack, but go to the heap. Normally this thing, for small strings, it'll just use the stack. But if this is a great big number, then it's going to do a heap alloc, or a malloc type thing. Okay. So now that thing is not constant. It can be written to. And this function is going to write to it. It said so. This is still the same value, it turns out. So that fixes that bug. Alright. So it should compile. Oh, load compile? Yeah, we haven't done anything. But it is true, I found it in one of those functions, and I can't remember which, in the ANSI build. I tried passing in like a string literal cast to a P car, and nothing happened. But for the wide car one, I got an access violation. And what it was doing was it was trying to put another terminating character at the end. Why, I don't know. It could be an internal problem with their code, right? They have a macro that they use, and that macro always has a put 0. Now let's go with this. Oh, change this. Why can't I see differences? Oh no, I see. Right. This one's got it. So it's gotta go in here. But that's okay because I shouldn't need this one in fact. If you don't include this file, then you won't get that, and that's good. And same thing here. It's fine. Just trying to sort these out. These are number defined. And this is just like a little utility thing. And these are values. These could be variable, like constants. Or not. This is just a cleanup thing. Alrighty. Now first let's just see, instead of going crazy like trying to download the whole website, let's try and just do some of this initial stuff. Forget about that. Okay, I understand what that means. We don't need the scope. Okay. Now, this is stir remote. There could be a C there, plus index file, which happens to be toc.html. Or HTM. If that succeeds, well, first let me do it in steps. That's what that's saying. And then what we can do is print that out. Okay, that doesn't look so hard so far. We declare an object that is an HTTP client. Now, this call here is to request, this request thing is sort of like get. In fact, that's all it is, get, but it doesn't return any value or anything. It returns true or false. In order to get the response, right, of course. I'm going to put that in the header. What is the pragma comment lib? I think it's when I met. I have a bunch of warnings I'd like to get rid of. Oh yeah. Any more? Oh yeah. Any more? No. Now it should link this time. Yep. No, it's going to complain once more. So, like I said, this thing performs whatever operation it does, and then returns true or false if it succeeded. And then, in order to, this doesn't need to be here. In fact, I always try to put, always declare your things where just before you're about to use them. Don't declare like in C, where you're only allowed to declare things first. Don't declare something like 100 miles away and then you start using it. I don't use this thing until this line, so I should be declaring it the line before I'm about to use it. And someone reading the code knows that nothing above here has touched this variable, right? So let's first let's see if that works, and then we'll go through it. Oops. Should be yes. Okay. Now, assuming the website hasn't gone down, this request here should succeed. Now I just did a step over, so yeah, whatever it's doing, one. But there's no, that says no error. I may have, in my copying, I might have screwed this up. Let's just see before I go and delete it. Yeah, it did work, okay. That's the data there. So this thing, what does it return? Return value. Returns true if successful. I got it backwards. So it doesn't say that there's an error. Well, that's correct. This part was correct. Oh no, it's not. Anyway, you saw that work. Oh, and that's not. Return succeeded. Great. Now, I don't know if this is necessary. It's something I have to test. I've always thought that when you call get last error, that it clears it out, but I don't think it does. No, I'm not sure anymore. It's easy enough to try. Set it to some number like 6 and call get and twice in a row and see if you get 2 6s. If you do get 2 6s, then this sort of thing's not in. Well, it is necessary because this assert may go off, right? And the assert calls all sorts of Windows functions, GDI functions, and who knows, it might set the last error code. Okay, so let's go through it again. So we'll run up to here. We shouldn't get any errors. We did not. Now this thing is going to return. This thing is a buffer, one of my buffer classes. Now in the buffer is a bunch of data, right? But and the data is in possibly binary format. So there's a function. If I know that it's supposed to be text, this function extracts it as text and puts a null terminator. Okay, so here's the text. I'm going to print it out. And there it is. Okay, so this has come from the internet, not from one of my files. And you can see that it's certainly not the most difficult class to use. Alright, now how does it work? How did that happen? Well, It's using the Windows WinINet base functions, and there are a whole slew of them. Sometimes they have this sort of thing. It's wonderful when they do. Here's a list of all the WinINet base functions. Okay. Open URL. If you can go through all of these and see what you might need, or what sort of functions you might need. And let's see which ones I use. First, I'm creating. I could have done this in one line. I'm just passing in a complete URI. URI, universal resource, something. I think it's URI. Oh no, this is a URL, and we need to turn it into a URI. Okay. So what we need is the protocol to use, the address, that's the URI, I think. No, that's this part. Address, don't know yet, and URI, we're going to find out in a second. Now with this is just like split path, and in fact the code is probably based on split path. No, it's not. It's something that I made. I'm not sure if it's correct, but it's pretty close. But you can see what the intention is. Whoops. Where are we? It's the intention is to take this universal resource lookup name and break it up into protocol, address, port number, and something called URI. Now let's see what happens with the one that we've got. According to this, URL is just, that's what we started with. So protocol is 4. Okay, and it's a string, so it's not 4, it's HTTP. Oh, here they are. Yeah, protocol is HTTP. Address is this bit. So that's the part of the URL that appears first after the double slashes, up to the next slash, I guess. So that would be like the root namespace, basically, under which the resource we want is located. And that's the one that you have to open. So if it was http://google.com, then this would be google.com, and that's it. No HTTP. And the URI, I guess, what is it? What's the acronym stand for? It's got to be universal resource something. Come on. Okay, well, it worked. Hey, that's funny. Does it really have a small I? I didn't type that in on purpose. It's an accident. Anyway, okay, identifier. Gee, how am I going to think that? So that's an identifier. It's a universal resource identifier. So we got address is that's the place that we're obtaining our information from. Now they call this agent, and in this case, generic I'm not sure exactly why, but of these, where did I get agent from? It's passed in by default, probably. Yeah. Where this is declared. That's the default agent name parent, generic. That's pretty easy to remember. Port number, we should, got 50. And that's what came out of this split URL. So 50, I think, is the default port for HTTP. We got that out of here. If we look at split URL, let's see where port is set. Now, if there's a colon anywhere other than at that beginning, then following that colon there should be a number. Up to colon, and then slash. Oh, there might be another slash, I guess. This would get everything following the colon and up to the next forward slash, and that apparently should be a number. And then you can turn that into a port number. Otherwise, you would use the default port for the given protocol. If it's now I've only got two. If we have HTTPS, this is not. I gotta fix this function. It works for HTTP and HTTPS, but it won't work for FTP, for instance. But anyway, for the default HTTP port number is 80. And 443 for HTTPS, and here are a few others listed that I'm not worrying about. What are these port numbers? That's, I don't know, technical stuff. Whoops. It's a number, and it defines some kind of addressing. The way that internet addressing works involves these URIs, and there's always a port number. And you don't have to use the default, but you can override that. Now, where are we currently? Okay, so what we're trying to do now is to connect. Oh yeah, now user and password are both null. Sometimes you might need a user name and a password. In this case, they're not. There's nothing. Okay, now we assert that at least these things have to be non-null. And they're not. Now to get a handle to an internet, we use this function. Okay, agent, null terminated string, specifies the name of the application or entity calling the function. Name used as the user agent in the HTTP protocol. So I guess no matter what, you use that generic, I think it was called, no matter what protocol you're using. This name is used as the user. Oh, no, I don't know what that means. Well, it's used definitely for HTTP, which is what we're doing. Okay. Now the access type. I've defined Internet Open Type Preconfig, which says proxy option. I think that's probably this. It's not listed here. Oh, here it is. Retrieves the proxy or direct configuration from the registry. Okay. Otherwise, I see. That might be a better one to use. No auto proxy. Prevents use of a startup JavaScript or INS file. Anyway, yeah, I'm sure we don't have to worry about that here. OpenType proxy passes requests to the proxy. Now, we're not using these proxies, and I don't know how proxies work generally, so this seems like the right one to use. It finds out from the registry whether it should use a proxy. I know what the word proxy means, but I don't know how to set one up. Okay, now we've got, for as far as the last two, proxy, we're not specifying anything. We don't have a proxy name or bypass, so just empty string. I think no, you can probably pass no. And flags. Now do we want async or from cache, you see? Or offline. Now what do we got? We got 0 synchronous read. What are these, the numeric values of these? It certainly can't be that. These are probably not 0. I don't know how come 0 means synchronous. But we'll accept that for now. Synchronous meaning the request will be complete by the time this thing returns. Okay, well, that did take a little while. And now we've got an internet. Now we're using this function, internet connect. Handle we've got, server name we've got, end server port we've got, username password we've got, service, that'll be this one, right? And HTTP service, and then these flags. If FTP no or that causes passive, I see. But I didn't tell you where to find these numbers, but here they are. No cache, right? So that means that the reading that we're doing is not going to go into the cache, and that's good. That'd be good if you want to do like private browsing. Oh, no cache. Well, I don't know. Don't write this item to the cache. And if I don't cache, oh, I see, same thing. Make persistent in the cache. Certainly, you wouldn't want to have this flag set when you're doing your porn browsing. Or getting from the cache, which is using the offline, or offline is the same as cache. So these offline and cache is one and the same. Okay, so I see. If you make something permanent and then you could save a web page, on your drive and use this make permanent, and then you can, from that point on, you can just use the cache, I guess. Well, here are a whole bunch of others. What am I using? No cache write and find keep connection. The description, the help's all in this header file. WinINetH. Where's that other one? Keep connection. Here. Use keep alive semantics. Whatever that means, I'm pretty sure that means that if there's an interruption in the connection, then it's going to fail. And the last thing, a callback function we don't have. All right. Oh, now did that returned a value? So now we have a connection. So we're connected to this here address, and we didn't pass the URI in yet, so that worked. So we're connected. Now we're calling this request of URI. So we would like to retrieve this object using method 1. And method again is a default, must be a default here, method. Oh, I see. Yeah, we're doing request get is the one. There's also post, different ways. Now how does this work? That takes us into here, and breaking it down by the request type. If it's a get, we request get. Okay. All we've done is just rename given functions for each of the types. Ours is a get. Okay, so let's see how a get works. Okay. Now this only has one thing in the array. The types of accept things. That's */*. Whatever it means, we'll find out where it goes anyway. Oh, you're supposed to pass an array of stuff. So we have the connection, the get verb, which is just the word get. The URI that we want, the version, I don't know. Okay, that's the operating system, or the compiler tells us. Reference, empty string, not sure what that is. I guess I can go to the help. Then this types, and this looks like a bunch of flags, and a callback just like before. Verb, so get, right? Verb is like an action. Open is a type of verb used for opening local files. Object name, the thing we want. Version, a header file. Refer. Okay, so this is a referring. If you had one URL and it pointed you to another place, you could put this in as a referring URL. You know, that's how those web browsers will do that. And then when the thing is retrieved, the server from where it's retrieved will find out some information about how that URL was obtained. So a refer, you put that in if you can. No, if no refer is specified. I don't know what do I, whoops. I should put no here, not empty string. It seems to work anyway. Accept types, a null terminate array of strings indicating the media types accepted by the client. If no, blah blah blah. Oh, I see. Servers generally interpret a lack of accept types to indicate that the client accepts only documents of type text. I see. No pictures and so on. And now here's a thing which is probably not working, because nothing from here ever does. And it's just the magic string is this one. /*. Okay, that means you can get binary, text, everything. Alright, so now we're sending a request. Okay, that request succeeded. Now we can add headers. Replace header. Oh, this is not my function. Accept. What is that? I see. Accept */*. Okay, return line feed. So add request headers, I guess. Put some additional things in the header. This is, no, it's not the same one. String variable length. So now if you know this language of this stuff, how this works, then this would be no problem for you. But they've got some number defines for various modifiers to that you can add. I'm not using that. I'm using this and just the one. Okay, I'm not sure about that, of why it's necessary, but apparently it is. Then it's just a matter of sending a request. We've created the request right here. We've added some additional stuff, but the thing is just a handle value. Where the memory stored is somewhere else, not in this class. My mouse. Where's my mouse? Okay. This here handle is just a handle, right? All the data that we've been putting into it is stored in the operating system somewhere. So now we just send it. Send request. Everything's 0 or null. No additional stuff. We did the additional stuff here, I guess. Okay, now it's doing its thing. This is happening internally. Now that works. So the get request return. So that's good. And now this here gets the response of the request, right? There's request and then there's response. This here is a buffer, and it's split up into two things: header and HTML. Alright, so given that we had that request thing, we now want to get the response. This here is just clearing out the buffers, and now it's going by chunks. So what we do is we call this function, which will return a certain number of bytes, and it'll tell us if we need to keep calling it for more. Okay, now we did this last time. We allocate a thing, this size, and now we're doing internet read file from our request into that buffer, size of buffer. Okay, no error occurred. Size is 400. So there is more data to come, right? Because no, it's possible, I suppose. This will just. It's possible we hit it right at the edge, so I don't know. Maybe I could have checked that. Something. It's never seemed to fail on me. Okay, so now this here just adds to a buffer. Buff chunk is a little bit, and this is the accumulating. Whoa! Well, it's not so difficult to see. I'll do it again. B more data says true, and we're accumulating. Buff here is currently 800 big hex, and now it's C100, so there's more. 1000, 14, still going. 18, quite big. Okay, it looks like we hit the end. Okay, query info. This here is for the header. And what that uses is some function, query info, which takes our handle to internet, and I don't know about this stuff, but I think I've gone through enough. You can go through the help file and figure these things out. I don't even care about the header. But here it is. Here's the header, so it's got a bunch of stuff. Now this closes the H internet, I believe. Header. First, if there is a request thing, I close that up. If there's a connection, I close that up. If there's if there's an internet, I close that up. All the handles are going to close, and it's done. Okay, and the result has been stored in those buffers. So here's the response. It's that many bytes big, which is decimal, 7,751, and I turn that into a string and I print it, and that'll be 7,000 something bytes, and that's it. Okay. As far as that second bit about the headers, I'll leave that as an exercise for you to sort it out. Code I can make available on request. Okay, see you.